I know you've done slope before, but it is crucial. You good? Okay. It is crucial that we know how to accurately do this every single time, or chapter 4, where it's all about graphing, is going to be disastrous. So rate of change is a ratio. Remember, ratio is a fancy word for equation. It talks about a change in one quantity with respect to a change in another quantity. A way of talking about rate of change is change in y over change in x.
Correct.
Change in y over change in x. Can you tell where people screw this up? Yes, it is change in y over change in x. People look at a table like this one. It says use the table to find the rate of change and then explain its meaning. And a table is pretty easy. I always tell people, do your swoops. What is my change from 78 to 156? What do you add or subtract?
2.
What do you add or subtract from 78? So I add 78. What is the change from 156 to 234? 156?
Plus 78.
Are you sure? Or are you just guessing that?
Yes, but I think that's the answer.
I wouldn't guess.
It is 78.
Yeah.
It's 78.
Okay.
Cool.
What is your change from 2 to 4? And from 4 to 6? 2. Rate of change, Ms. Hoff shortcuts as ROC. Rate of change is the change in y over change in x. The first change in y was 78. The first change in x was 2. So you would write 78 over 2. The second change in y was 78. The second change in x was 2. So you would write 78 over 2. 78 divided by 2 is 39, technically over 1, yes? And I'll talk about why we want it over 1. Normally, you'd say, Ms. Hoff, don't put that over 1. But when it says explain its meaning, we got to talk about labels. Change in y was on the top. What is the label on your y value? Cost. So I'm going to put the dollar sign. Change in y is on the bottom. What's your label on the bottom then? Number of games, or in other words, games. So what is the explaining of a rate of change of 39 over 1? Very good. And there's multiple ways you can state it. Both of you just said two different things. For every one game, it costs $39, or it's $39 per game. Either case. Is it always going to be over 1? No. Okay? It is not always going to be over 1. So that's why we just be careful. Always simplify. A rate of change is constant for a function when the rate of change is the same between any pair of points on the graph. Linear functions have a constant rate of change. So the directions are going to say determine whether the function is linear. If you're trying to determine linear from a table, we have to determine if the rate of change is the same between every single pair of points. So we'll do the swoops on these tables as well. We take the first one. What is my change from -6 to -8? And -8 to -10? -10 to -12? -12 to -14? And the other side. 1 to 4? 4 to 7? Plus 3? 7 to 10? And 10 to 13? Now you have to show me every single fraction setup, meaning the first change in y, the first change in x, the second change in y, the second change in x, the third change in y, the third change in x, the fourth change in y, the fourth change in x. I want to see every single one. So it would be -2 over 3, -2 over 3, -2 over 3, -2 over 3. Can I reduce -2/3? How about the next -2/3? How about the next one? Or the last one? Is this linear?
Yes.
How do you know?
Because the changes are all the same.
Constant rate of change. Question, Jackson.
Yeah, so when they write this, would it technically be linear if
points over 1, right?
But I don't have anything to the, where did you get 2/3 to the fourth power?
There's 4 of them.
We're not multiplying them. We're just writing down all 4 of them. Okay. Try this one on your own. Determine if this is a linear function. In other words, tell me if you have a constant rate of change. When I calculated this, I got 2/2, 4/2, 2/2, 4/2. Agreed? Can you reduce 2/2 to 1? 4/2? 2. 2/2? 1. 4/2? Is this linear?
It's a pattern.
It's a pattern.
But it's not a constant rate.
It's not a constant rate of change. Who cares if there's a pattern? It has to be the same exact rate of change every time.
What would happen if there
Not linear, not a constant rate of change.
what would happen if it went 1, 2, 3, 4? Would it be linear?
Is that constant? Is that the same?
Yeah.
That's the same? You having $1 and me having $2?
No, it goes up by 1.
That's not what I asked. It has to be the same rate of change. All right. The slope of a non-vertical line is the ratio of the change in your y, which is your rise, over the change in your x, which is your run. How many times have you seen this slope formula? A gazillion, right? Everybody always says to me, Miss Hoff, why are there little 2's and little 1's? They're labels. This is the y coordinate from the second point minus the y coordinate from the first point. The x coordinate from the second point minus the x coordinate from the first point. They are not exponents. They are subscripts. They're smaller. They are labels. You guys are going to do a lot of balancing equations, I'm assuming, the next couple of days? You already did? Oh, cool. Find the slope of the line that passes through each pair of points. Something just to get us warmed up. Label your points x, y, x, y. Remember, your x coordinate is the first number. Your y coordinate is the second number. Does it matter which one you start with?
Yes.
No.
No.
As long as it's a y, I don't care. Which y value do you want to start with?
Y 1.
0 minus 5 divided by. Now, if I started with 0, that means my x has to be -2 minus 1. 0 minus 5. -5. -2 minus 1. -3. Can you reduce that? -5 divided by -3 is actually a positive 5/3. A negative divided by a negative is a positive. Now, I just want to show you when I say doesn't matter which one you start with. If I would have started with 5, still a y value, right? 5 minus 0, what would my x value that I start with be then? 1 minus -2. 5 minus 0 is 5. When you subtract the negative, what really happens here? Add a positive. 1 plus 2 is 3. Can you simplify? In that case, no. So no matter which way you do it, as long as you start with the same x and y. Try the next one on your own. Find the slope between -3, 4 and 2, -3. Okay. I got 7 over -5. Can I reduce that?
No.
You know what I would do? I'd move the negative. I would put the negative with the 7. Technically, it does not matter as long as you only have one negative. Some of you may have gotten -7 over a +5, which is fine. It's the same thing. As long as there's only one negative. Could you technically put it out front? Yes. You could write it as -7 over 5 like so. But you can't have -7 over -5 because a negative divided by a negative is a positive. Okay? Flip it over. Do it again. Top left. Anybody panicked yet? No? A little. Are you supposed to panic about this? -1 minus 1. Oops, I screwed that up. -1 minus -1, which really is adding, which is 0, divided by -5. What is 0 divided by -5? 0. If you have 0 of something and you want to split it into groups, you don't have anything to split up. So you're going to make 0 groups. Okay? Do the next one. This time, where is your 0? At the bottom. Some of you may have gotten -7, which is fine. Can you divide by 0? No. In this case, your slope is undefined. Number one rule in mathematics is you cannot divide by 0. It's like me saying, like, look, here's my group of 0 friends. It doesn't exist. There's no such thing. It's not a group if there's 0 items in it. Okay? Now, what does this mean in the line world? Okay, so here's a graphic for you, and I know yours maybe didn't run off quite as well. If your function values are increasing, the line slopes up left to right. If you have a positive slope, when you look from the left side to the right side, that line should be climbing. On the next one, if your line slopes down, guess what type of slope you have? Negative. And you always read a graph, just like you read a book, from the left to the right. Now, the difference is here, a horizontal line and a vertical line. There's two different things I'm going to talk about with this. Remember, slope is always rise over run, which is your up and your down versus your left and your right. If I put 2 points on this line, if I went from point A to point B, okay, we're starting on A because it's on the left. The rise. How far up or down do I have to go to get to B? 0. And then we'll say we go 6 to the right. 0 divided by anything is 0. Okay? A horizontal line is a slope of 0. Ms. Hoff always talks about it's like somebody who skis. If you're skiing on a flat hill, you're going nowhere. 0 miles an hour, right? Unless you use your own muscle to move, you're not moving anywhere. 0 miles an hour. Let's talk about a vertical line. Point A, point B. Talking about rise over run. If I want to go, we'll put A down here at the bottom, sorry. If I start on A, we'll say we have to go up 7 to get to B. How far left or right do I have to move? 0. Can you divide by 0? No, that's when you're undefined. Go back to your skier. If this was your hill and somebody tried to ski on it, they would be undefined. You would be undefined, yes? Okay? The easiest way to remember is thinking about skiing. If I'm skiing on a horizontal line, I'm going nowhere. It's 0 miles an hour. If I'm skiing on a vertical line, I am undefined. I am not surviving that trip. That's a really great question. Okay? So those are the 4 different types of slopes you could have. You've calculated slope a gazillion times. Agreed? Okay. One little twist today. So what is the value of R so that the line passing through these 2 points has the given slope? So I'm going to give you a coordinate 1, 4, and then -5R and say, hey, I want a slope of 1/3. You have to figure out what R is. It goes back to the slope formula. X, Y, X, Y. In the slope formula, which numbers are on top, X or Y? Y. So let's start with 4. 4 minus R over 1 minus -5. What do we want that slope to be? 1/3, what they gave us. We used the slope formula and then took the slope that they gave us.
Would that be plus 1?
Just wait. You're going to take the words out of my mouth right now. 4 minus R. Can you simplify that at all? Maddox, 1 minus -5 really would be 1 plus 5. So I would simplify this before doing anything else to go 4 minus R over 6 equals 1/3. Okay, last week, 1 fraction equaled 1 fraction. I can cross multiply the butterfly. Nicely done. We will cross multiply now. Be careful here though, because you're going to have to take 3 times 4 minus R, correct? Remember that? And then 6 times 1. So you have to distribute that 3. When I distribute that 3, what do I end up with? 12 minus 3R equals 6. There's not a, what do you mean plus R? Now what do you want to do? Subtract 12. What do I have left? What's on your left? -3R. Then divide by -3. R would equal 2. If that coordinate was a 2, we would have that same slope. You have to show me cross multiplying to prove this, though. You have to show me cross multiplying to prove this. Try the next one on your own. before you get too far, I set mine up as -6 minus -8 over r minus 5. But what do I set that equal to? Bingo, -8 over 1. Just checking that you knew to write your whole number over 1. You shouldn't get a decimal. What should you get? A fraction in reduced form. This is why you have to show me cross multiplying, because there is no way you're going to figure this out in your head without it. Are you matching me? Or no?
Yeah.
Am I okay?
Wait, wouldn't the 2 be negative 2? Because you're adding 6 math. Oh, wait, actually, never mind. I mixed up the negatives.
Am I okay so far? Because then this would really be 19 over 4.
That's
Yes.
27.
Some of you may have gone -8 minus -6, 5 minus r. Equals 8 over or -8 over 1. So then this would be adding -2 over 5 minus r equals -8 over 1. Oh, sorry. -2 equals -8 times 5 minus r. -2 equals -40 plus 8r. Add 40, add 40. 38 equals 8r. Divide by 8. R is 19/4. Whoops. So it doesn't matter which x or y you start with as long as you follow in suit with your x on the bottom. As always, sometimes in algebra we're like, oh, we've done this before, and we get going too fast and we make avoidable mistakes. I don't like to call them silly. I don't like to call them anything terrible, because we're humans, but they're avoidable. It's not always about speed versus accuracy. Okay? All right. 3 online. Yes, you will have work. Yes, I have work paper in the back. Those of you that are going to be gone for football on Tuesday, I will have stuff for you tomorrow, because I don't have it run off yet.